Okay, so the first week we saw introduction to Power BI desktop. That was what we started with, and we also that same day we also looked at how to connect to different sources. Although we only worked on CSV and also folder, but I showed you how you can always get access to others like SQL Server and all of those things. The most important was like that CSV which I showed you, so you can always build up on that. And we also did some transformation processes in Power Query. We did some stuff with the date table and all of that. And last week we completed transformation processes and loading, and then we also touched on data modeling, where we explained keys, right? We explained keys, we explained tables, the type of tables that we have. So I'm just going to call on anybody based on what we did last week who can remind me what are the two types of tables we have. What are the two types of tables we have based on what we did last week? What are the two types of tables we have? Okay, anybody?
Okay, hello.
Yes, I can hear you, sir. Thank you.
So I happened to watch, I wasn't in the class, but I saw the video. So
okay.
There's the fact table and there is the dimension table, if I'm correct.
Yeah, that is correct. So what is the difference?
Okay, so the fact table contains ID that is I think that is not distinct. It can be repeated. However, the dimension table can only contain distinct I think no. So I think it's foreign key. I think there's a foreign key and there's a primary key. So which is supposed to be like a unique or a distinct number. So that is contained in the dimension table. So which means that you can only find that particular number coming up once. However, in the fact table, it can come up, more than once, several times. So I think that's what I took away from that.
Thank you so much for that. Even though maybe you were trying to mix up some things up, I really appreciate that you really, even though you were not in the class, you were still able to follow the video and still come up with that. So I'll just give you 0.8 over 1. So if that is okay by you, so you can still always build up on that. So any other person? Thank you so much for trying. Any other person, guys? I think I have it on my screen, right? This is partial, so let me just take it off. Okay, so any other person? If you can just look at some things that he mentioned and try to probably correct it. Any other person? Okay, no other person. So I will just do the recap of what we did. It won't be as deep as last week. So just going to be a quick recap, even so that those who were in there, we also benefit from it. So we're looking at data model, and we said data model is basically a representation, right? A visual representation of that, or let me say the connection between two or more data models. That's basically between two or more data tables. That's basically what a data model is. And I said, is this a data model? No. So, but this is a data model because as you can see, there is a connection between these tables right here, right? You can see a connection between them. So that's basically what your data model is all about. And we talked about data normalization, which was what the assignment was based on. I won't be going deep into this again. I'll just skip to the tables. So we talked about different tables. We already saw why we need to have different tables. That's data normalization, right? So now that you have different tables, you need to create connection between these tables. So these tables are of different types. And we talked about data tables and lookup tables. The data table is also known as the fact table. You might find another resource that they call it fact table. It's still the same thing. And for the lookup table, some resource call it dimension table. Okay, so they are both, that's like the other name for it. So what is the difference between these two tables? So I said, when you have two tables, you have a table And one important thing, we check that video, is the fact that since we are breaking a big table now, we are normalizing, we are breaking it into different tables. In order for us to connect them again, there need to be a what? And something like an identity. You understand? Something that connects the two tables together. I mentioned that, and that is known as key. Okay, so what ascertains whether your table is data table or lookup table depends on that key. You understand? So in a case where you have the key appearing more than once, that's a duplicate. Just like in this case now, if you check this table now, this is like a date table. So if you check this table now, you can see that 1st of January 1997 is appearing a lot of times. If you have really identified that this colon here is your key, then this table automatically becomes a data table because this key here is appearing more than once. Do you get it now? That's provided that you have decided that this colon is your key. Don't forget, I told you that your table can contain more than one key. We are still probably going to see one of the tables that does that. So as far as this date table is concerned, this calendar table, you can see that what this old table now is one table. This is another one. This is another one. This is like a calendar table. This is like a product table. This is like a general table. You understand? So you can see that the date here now, they are duplicated. So this calendar now, you can see this calendar table, we have a date column. This one now, we have a date column. So if I want to connect these two tables together, definitely my key, what will aid my connection will be this date column, right? Because you cannot connect this date now with day of the month. They don't match. And you cannot really connect it with year and week ending. Even though this is also a date format, it doesn't necessarily mean that like this is what it implies. This is like week ending. I don't really want to touch on that, but so far, this is what your key will be. This is also what your key will be. Now that you've determined that this is your key here, you can see that the key is duplicating here. That automatically makes this a data table. But if you check your date here, you can see that there's no repetition. So you have your 1st of January, 2nd of January, 3rd of January in month, day, year format. 5th or so. You can see that there's no repetition here. So that automatically makes this on what? A lookup table. Okay. Similarly, if you check your product table now when we want to connect this table and this one now, our key will change. Our key is no longer date, but what? Product ID. So if you check your product ID here and you check your product ID here, these are the two columns that will create a connection. That means that is our key. So now let's look at it. We can see that here, even though it might not show it, we will definitely have some duplications here. That's the idea. This is not the old table, which was just truncated, but this will definitely be repeated. But if we check here now, the product ID is not repeated, just 1, 2, 3, like that. So that automatically makes this one a what? It's still a data. We have already established that it's a data table. Then that automatically makes this one what? A lookup table. Okay, so now you can see that this table now contains different keys for different tables. So that's what I meant by a table can contain more than one keys, just like you have seen here. So now we've been talking about key. Now I believe you understand the tables now, right? Now key. Let's now define those keys. So when your key is duplicated, right? In this case now, is duplicated. That makes it a foreign key. So that's to say your foreign key is usually located inside of your what? Your data table. So simple. But that key that doesn't duplicate, which is usually found inside your what? Your lookup table, is known as what? Primary key. That's as simple as it could ever get. So just try to listen again, try to look at these diagrams. And of course, we'll be going into Power BI now. So we'll be leaving this thing. So probably when you get hands-on stuff, you get more familiar with it. But trust me, this is a important part of analytics journey, data modeling. And I can guarantee you that 80% of your interview questions will be based on data modeling. Whether they will ask you the type of keys, they can ask you the type of tables, the difference between them. Like Amazon big companies, I'm very serious with you here. So is a very tricky part of analytics. If you get it wrong in your modeling, your whole data will be wrong. I mean, all the insight you are going to generate will be wrong. So it's very, very key. You understand? When you talk of data analysts, when you talk of data scientists, when you talk of data engineers, this is one aspect that brings all of us together. This is an aspect that brings all of that's why it's very, very important. And it is what you learn here is transferable to your SQL. For those of us that have not started SQL, by the time you get to SQL, I'm sure you remember all of these things that we've done here, and it will make it quite easier for you. And those of you that are already doing SQL and you've probably gotten to a point of joins and all of that, you can confirm that this is just exactly how it is over there. Okay. So these are the keys now. So here, this is known as what? Foreign key. You can see they are located in the data table, but these now are what? Primary keys. They are unique. Primary keys are unique. Just remember that way. Okay, so I really don't want to go into this. Was prepared for the class part by that. So I don't want to bore you guys, to be honest. Okay, let me touch this. But maybe I will come back to this because this is also another a common interview question talking about Snowflake and star schemas. So I will come back to it. No worries. So let us just go do some hands-on stuffs now. So let's go over to Power BI. I'll just bring over my Power BI here. So any questions, guys, at this point? If you have, just signify, raise up your hand, or just call. You can even, okay, don't interrupt, but you can just send a message on chat and you can always pick it up from there. So now, by now you should know this is our report view. We've not really done anything here, but data view, you should be familiar with your data view now. I think we looked at it the last time. This is where you have all of your data. We'll be working soon on it when we go to DAX. And this is your model view. So now we've loaded all of those data together. Let's assume we've finished all our transformation and all of that. So we want to model now. So you can see they are not modeled. Who can tell me why they are not modeled? Or let me even ask, are they modeled? That should be the question. Is this a data model, guys? If yes, tell me why. If no, tell me why.
I think they are not modeled.
Why?
Because there are no design relationship between specific tables.
Yeah, perfect. So there are no relationship between them. So this is not a data model. This is just like a group of tables, right? So we need to create a connection between them. Okay. So in case you did not see what I did, because we have a lot of data here, so the screen might not take everything. So you can always minimize it here. By your bottom right, you will find this navigator for zooming in and zooming out. So you can zoom in to, have everything small, shift them together, then you can zoom out again. Okay, so you can do that. Now we have all of our tables. Now we need to create a connection between them. So this is where the part that says you need to understand your data. This is where it comes in. You don't just, no matter how good you are as an analyst, you cannot just see a data and just jump on it and start to analyze. It's not possible, except it's something that you can easily relate with. So what I'm saying in essence is you need to have an understanding of your data. You need to have an understanding of your data, what the data does. And that's why some people will come out to say one of the best way you can be an analyst is to integrate analytics into your field. You will really stand out because if it's your field, you already know the hidden things in your field, what it's all about. And by the time you're bringing in the analytics, you definitely stand out than someone that doesn't have an idea of what your field is all about. So it's important to have an understanding of your data. So luckily, some data come with what we call data dictionary. I don't know if you've heard of it before. So data dictionary is just like a document that will show you the details of what you have in your data. Let me see if I have one here. I think, just give me a moment, please. I think I have one. Is it in restaurant? Aha. So I have this is one I have with me for one restaurant data. So you can see this is like a data dictionary. So it just shows you like these are all the tables in that in the whole thing. So we have consumers table, we have consumer preferences table, we have ratings table, and it gives you a description of what each of those tables represent. This is a very simple one. You might have seen a data table of a data dictionary of about 100 and something pages for AdventureWorks, which is this one that we are doing, because it's a popular data set. If you check online, you see it, AdventureWorks. So, but it's like the full, like it's crazy. But this one is already sorted out. I think I got this from Maven. I mentioned it at the beginning of the whole course. So this data is from Maven. So they already did some cleaning and all of that. So we don't have to do much cleaning and many things. So, but the real data comes with a data dictionary about 100 and something pages. So, so that data dictionary is designed to give you an understanding of what. So even if you don't have, like, you don't work in the company, for instance, or you don't even work in that sector, with that data dictionary, you have an understanding of what the data is all about. So it's important to know what your data is all about. So we have to go back to this data. You come to your data view, and you need to check all of this data one by one and have an idea of what this data mean. Okay, so because in this case, we don't have data dictionary, right? So we have to have an idea of what all of this data mean. So let's start with this one. This calendar is duplicated. I think this one is the one let me just delete this one. You can always delete. If you right click on it, you will see delete from model. So I'm deleting the one I have here. I'm deleting that calendar. You probably don't have it, so don't worry about that. So I can rename this one now to just calendar. Okay, perfect. So now we have our calendar table. Of course, this just tells us what the calendar, right? So like dates from 2015 to, you can check it to maybe to 2017, 30th of June 2017. So this is just a simple calendar table. Just shows us the calendar. We were the one that we did all of this in Power Query. If you remember in the first class, we calculated all of these things. So this is the only column we had initially. So no problem, I'll leave that. So now this is customers. So what table is this? This is a table showing all the customers we have in our database. You get it now. So you can see customer key, prefix, first name, last name, birth date, and so on and so forth. So every row here, every record here represents the information about a customer. So now, guys, tell me, how do I ask that question? Okay, who can tell me? Let me see if someone can just find a way of thinking about it. So who can tell me what type of table is this? Customers table. Is it based on what we've discussed so far? Look at it. If you have your Power BI, try to open it and click on these customers and tell me, is it a data table or a lookup table? What do you think, guys? There's no right or just tell me the answer. It's not a problem. We're all learning here. So please feel free to talk.
I think it's a data table.
Okay, why do you say so, Sam?
Yeah, because like most information on the table, like it shows the information of the customer per se, and it's like giving a like I would like a English is that okay? It's giving a base for all other column like in the table.
Okay, all right. So okay, thank you. I have Mr. Tim Edoja. He says it's a lookup table. Please, can you unmute and tell us why you think it's a lookup table, Mr. Tim? Can you please unmute yourself? Okay, maybe I am muting myself. Can you tell us why you think it is a lookup table? It's like it's not responsible. Maybe he's not able to talk. Okay. Any other person apart from Mr. Okay, he said he's in a noisy place. What do you say?
Okay, so I'll say is a lookup table because it has mathematical functions.
In what sense? In what sense?
So we have the annual income column, and sorry, I'm not with my glasses, so I'm trying.
Okay.
And we also have the the date is a string, so so I'll just say it's a lookup table because we are going to do impute. We are working on the values on the annual income column.
Okay.
I don't know.
No problem. Thank you for your contribution as well. I think someone else wants to talk, right? What's that? So we have 2 lookup table and 1 data table. One more person, please. Any other person? Thank you so much, Miss or Mrs. Queen, for your contribution. Any other person? Mr. Achinoye, your mic is on. Do you want to say something before I continue? Okay. All right, guys. Thank you so much for your contribution. Like I said, we're all here to learn. Okay. So the earlier you make the mistakes, the better. Okay. So you can. Well, it is because I actually know this, that this is a customer table, right? Literally, I might not have known whether it is a data table or a lookup table. Why? Because I don't even know the key. You know, I told you the determinant of being a lookup table or a data table depends on the key you are considering. Do you get it now? So I don't know the key. So how do I know if it is a lookup or what? Non-lookup. So that's the number one thing. But because it is a customer table, now let's come logically. Now, because it is a customer table, that it shows a description of every customer. This table shows that means if I'm going to this store now to register, maybe I want to buy something now, they're going to register my name.
Why don't you shut your mouth?
Okay. They are going to register your name. Let's say for my case now, Mr. Idris James, for instance. That's my name. They'll put my birth date and all of these things, they'll put it there. And they will give me what? A customer key. So that means this is our customer 2000. Now, when another person goes, maybe this time Mr. Toyib goes, they put in his name and it takes keyword 2001. When another person goes, you know, and so on and so forth. So meaning this customer key here can never be duplicated. A customer cannot have the same key. 2 customers cannot have the same key. So this key is just like an identity for each customer. So instead of having all of these details, if I know, okay, who is so person, most times when you see, maybe they call it ID, or you see something like this, is usually your key. Most times. Okay? So looking at this now, you will know that this for sure is what? Is a key. So you now need to look at it now, because you cannot make first name your key. It doesn't make sense. If first name is your key, it doesn't, like, different people can have different names. Like it's not like a match. So the best thing here would have been a customer key. Since you have a customer key here, you cannot use like annual income as a key. Well, it depends on what you are considering, but in this case, you cannot. So you have customer key here, which shows that this is the identity of each customer. So how do we now confirm it? That was going back to what I said initially, that it's very difficult for you to ascertain until you know what your key is. So if we check, for instance, if we check your product table, we don't have anything like that. Now I check on maybe sales. Don't forget, we don't have a data dictionary. That's why we are going through all of this. If you had in a team setup, you definitely have a data dictionary that tells you what each of these tables mean. So it will be easier for you to catch it that way. But not all scenario that you even get a data dictionary if the organization is not so organized. So you need to figure it out yourself. So now if you check this sales, what does sales mean? Sales means this is the record of all of the sales, right? All of the orders that all of the things that people purchase. So now what does each record tell you? Each record tells you the date that this order was made, the date that the stock was made, that's that product, the day it was stored. I don't know what, but let me just assume that's what it means. Let me leave that. Then we have the order number. Then we have the product key. Order number is more like, this is the order number what that we are buying, that, order number what. I'm sure many of us, when we go to buy some things in the store, you see an order number. So that means in that store, that is the identity for that order that you are making. Then you have product key. That tells you that there is a product. This product, now you cannot just write product. Okay, I bought a car. Or I bought a car that is red, that is 200,000 pounds, that is made in USA. Imagine you have all of this information here. No. So that's what this product key represents. That means definitely there must be another table here that we have what? Give us the information about product, but that's not where I'm going. So I'm coming to customers. So now you can see that we have what? Customer key. That tells you that what? This number here tells us who made the order. So if I want to know who made this order now, what do I need to do, guys? I need to connect this table to the customer's table. On what? On this column. I don't know if what I said makes sense. Because I want to know, look at it now, this is the order. This is like sales table. You can see we have customer key here. So that means customer 114455 made this order. If I come to my customer's table now, and I try to toggle on 1145, let me see if I can quickly do that. Okay, I can maybe not really do that, but let me just go on one customer. You can see just this customer, this is the details of that customer. Do you get it now? So if I need to know which customer made an order, all I need to do is what? Connect this sales table with what? With the customer's table using this what? Using this key, this customer key. So it's going to match them on that. That would be like our matching. If you remember last week when we were trying to match together. But if you've not seen that last week video, I encourage you to please see it. When we're talking about matching, you know, in the university, in secondary school, they can draw like an elephant here, they can draw like a car here, and they write here, they write animal, they write maybe something, and you try to match them together. So you must have seen something that is in this one, that is also in this one, that makes you match them together. That's exactly what we are talking about. So there must be something in this table and something in the other table that can help us match them together, which in this case is the what? Is the customer. So no doubt, this customer colon is our key. Forget the key. They might not even write customer key. It might just be customer ID. But your ability to identify it is the beginning of your analytics journey. That, oh, this definitely is my key. If it was so easy, then data modeling wouldn't be as complicated as, it's not like it's difficult, but I'm just saying that if it was so easy, it wouldn't be the like bedrock. You know, I told you modeling is like the bedrock. If you can miss it, then your whole insight, and no matter how beautiful your dashboards are and all of that, they are all wrong because they are giving us a wrong insight. So if you did not identify the correct key to join together, to model together, then there's an error. You see why it is very important now. Don't worry if it's sounding so strange this time. We are still going to do so many connections, okay? So just let's be patient, and the better you work on more data, the more you understand this, okay? So do you have any questions before I continue? No question. Okay, so meaning this customer key now, it needs to be what? Joined with this, our sales table. Now that we have now decided that this colon now is the key, now we need to check it. That's the second step. After we identify the key, now we need to what? Check it. So if you click on this column now, if you scroll down to your bottom left, Power BI gives you the description of that table. It tells you now that, can you see it at my bottom left where I'm hovering my mouse? Can you see it? Can you see it? Bottom left.
Yes.
Aha, you can see it says what? 18,141 rows. And it says what? 18,148 distinct values. So that means what? There's no repetition. So since it is our key and there is no repetition, what table is that?
Lookup table.
Lookup table. And what key is this?
Primary key.
Primary key. Do you get it now? That's the first thing. So we've been able to identify that this is our key. This is a primary key, because there's no duplicate, then automatically this table becomes what? A lookup table. That's this one. Let's check another table. Very simple one now, customer category. So you can see now that this what's product category all about? It's telling us, okay, in that company or in that store, they have products. Then each product have category. I think I was explaining last week. For instance, you go to a store, they sell unisex, they sell male clothes, they sell female clothes, right? So under male clothes, they have maybe male clothing, they have maybe trousers, they have maybe what else? Maybe singlet, or these male stuffs, right? And under the female too, they have that. So for those excuse me, for those products now, there is a category. What is the category? Male or female, right? So it's like a group. What groups them together, right? Category. So this is exactly what excuse me. This is exactly what product category means. So, and you can see here now we have 4 categories in all of our products. So that means we have bikes. We have some products that fall under category bikes. We have some products that fall under category components. We have some products under clothing. We have some products under accessories. So this is very easy. Without asking much question, who can tell me what table is this and what our key is here? What table is this and what our key is? Anybody?
I think it's a lookup table.
This
And
I think the key is a product category.
And is it primary or foreign key?
It should be a foreign key.
Look at it very well.
It's a primary key.
Primary key.
Primary key, because they are not duplicated, right?
Okay.
So that's category. Please when you are doing it normally, you have to be writing it down. Okay. Once you are working on your stuff, you'll be writing it down, because you always not remember all of these things. And even if you remember later, it will save you time. Okay, you need to judge, maybe when we start to maybe work on some project, we'll just be looking at some best practices. We are all still learning now, so no problem. So we have another table here, which is subcategory. So this is just like a category, but now it's subcategory, right? So that means under each category, we will find a sub, then before you now find the product itself. That's called hierarchical data. So so you can see that we have subcategory key now, right? Then the subcategory name. So now, because the subcategory now is under each category, right? So you can see that each subcategory has a category key. So that tells us that, okay, this subcategory mountain bikes belongs to what? Category 1. This road bikes subcategory belongs to category 1. So it's more like saying this product key here, this is it here. Can you see here? The product key that was primary here, it is now duplicated here, which automatically makes it what here? A foreign key. Inside of this place, it was a primary key. But here now, it becomes what? A foreign key, because it is what? Duplicated. You can see. But because this one now is a foreign key, does not necessarily mean that our table is data table yet. We cannot say that yet, because I told you that you can have more than one key in a table. So as you can see in this table now, we have more than one key. Don't forget, what determines whether your table is data or this thing is what? Is the key that you are considering. The key that you are considering. If your table has more than one key, what key are you considering for your connection? Then that's what is that key that will not determine whether it's what? It is data or lookup. If I just look at this and because this one is key, okay, this is product category key, right? And it is duplicated. Oh, definitely this table is a data table. That's wrong conclusion. Because is it this key that you want to use to join? That's the question you need to ask yourself. So if we need to join this subcategory with category now, we definitely need to use this No, don't let me jump down first. Let me still skip it for now. So another key here is the what? Product subcategory key. That means this is the key that represents what that tells us what each subcategory represents. So guys, tell me, between these two, which one do you think will be our main key here? Between this and this, which one do you think will be our main key here?
Product subcategory.
Product subcategory. Okay, because of course this is a subcategory table. So this is going to be our. So now we look at it. Is it duplicated? No. That means it's what is a primary key, and automatically it means what this table is what is a lookup table. Okay. All right. Don't worry. You understand it, even if it's sounding somehow. Then we have products table. Now this table tells us all the products that we have in our store. So the idea is just similar to customers too. The same way you cannot have two customers. I'm just forwarding now. I'm supposed to be asking questions, but let me just skip that question thing. So because of time. So the same way, just look at it in a supermarket. Can two products bear the same name? Like this is Samsung S5 and another product, Samsung S5. Is it possible? No. Can they bear? So each that identity now is like, you know, when you say something and then it's like it is only for that particular thing. So in this case now, we have product key. You can see that each product key represents each product. It gives us information about each product. Look at this 2-1 for now. It tells us that this product belongs to subcategory 31. The SKU is this. This is the product name, spot 100 element red. This is the model name. This is the description. This is the color. This is the size. This is the style. This is the cost of the product. This is the price of the product. Then you have another one too, product key 215, and so on and so forth. So guys, tell me, what is our key here? By looking at this, what do you think our key will be? And what type of key is it? And what type of table is this?
I think
so.
Okay, please go ahead. Two people wanted to talk, and all of a sudden, no one is talking again. Come on, guys, come on. Or maybe I should have even asked you to analyze it yourself. Maybe my explanation made it even worse. Okay, guys.
Okay. The main key is the product key, because each product key is like unique to each product. So it is a lookup table, and our main key, or the key that we'll be considering, is the product key.
Do we agree with that?
Yes.
Yes, I do.
Perfect. So now you can see that we have two. You can see that we have two keys now. We have product key and we have product subcategory key. So if this is the key we are considering as our primary key, because that automatically means this is a foreign key here, because you cannot have two primary key in the same table, but you can have more than one foreign key. Please be jotting down all of these things I'm saying, as like you can be telling them in your interview. These are things that you're going to say that really shows that you know what you're doing, or you understand what these all things. Well, it goes beyond the definition of, okay, it is unique, it is not unique. You can only have one primary key in one table, but you can have more than one foreign key. Do you get the idea now? Because primary key is like the main key, but foreign key, you can have more than one. So just like in this case now, we have a foreign key here. This automatically translates to a foreign key, but this is our primary key. Okay, perfect. So let's check this returns table. So in our returns table now, we have return date, we have territory key, we have product key, and we have return quantity. So I want someone to tell me here, what type of table is our returns key? What am I saying? What type of table is our returns table? So look at it critically and tell me, what type of table is our return table? Let me tell you what this return table means. because sometimes you need to know what do that table. So this return table is like saying, after they purchase the product, right? Maybe there's an issue with it and they returned it. That's the meaning. So it takes records of all of the things that they've returned, including the date, as you can see, where that product is returned from, that's territory, and what is the name of the product that was returned, and what is the quantity of the product that was returned. So guys, tell me in 1 minute, what type of table is this?
Data table.
Data table. Okay, let me get like 2 more responses and you tell me why.
I think it's a data table because the both territory key and the product key that is supposed to be our keys there are repeated.
Okay. All right. Thank you so much. Any other person? Any other person? Okay.
Yeah, well, I kind of agree with them. The data table.
Oh, okay, perfect. Yeah, it is a data table. So thank you so much for those answers. It is a data table. So, but what key? Because as you can see now, we have like 3 keys here. We have product key, we have territory key. Your date is also a key because you have a calendar table, don't forget. This calendar table is, I did not even ask this one. This one is a primary, is a data table, is a lookup table because it gives us identical, unique dates. If you check now, we have 912 rows and we have 912 distinct values. So it just gives us, this is just like a calendar table. It just tells us each date that we have. Any calendar table that you know is usually a lookup table, no doubt about that, because you cannot find repeated dates. As you can see, first, it's just like a calendar. Can you see 2 dates repeating itself in the calendar? No. So dates also can be your key, which is exactly what is happening in this returns table. You are right, it's data table, but I want you to know why it is data table, not necessarily because of these 2, but because of this. So because return now, the major thing that we need to, that can help us, that can give us more information from this return is, when are they returning this thing? Do you get? You can consider it from that angle. When are they returning this product? So you can return more than 1 product in a day, very likely. So that's why this column in this case will not be duplicated. And as you can see here, we have 1,809 rows and we have 476 distinct values. So which make date also another key, which is also another foreign key. So we have 3 foreign keys in this table, but yes, it is a data table. Thank you so much for your answers. And we should have joined, I thought we merged these 3 together. Is it not? That day, I think we imported a folder now. Let me check it because
yes,
instead of
having,
maybe I did not save it, my bad. Okay, let me see. I think I have the folder here, 2015, 2016. Okay, so let me just try to bring it in. Let me quickly, okay, let me just read the last one. Okay, second to the last, territory. So territory gives us information about each territory. So definitely you should know that this is what table?
Lookup table.
Lookup table.
Look, each once you each something, you can see each. So you cannot have the information of two territories repeated. This one gives information of each customer. This one gives information of each product. Do you get it now? Aha. So this is, you're right, it's a lookup, and you have the key here. All of these are not key. The only key here is this, which is a primary key. So for the sales all have identical fields, colon. So let me just quickly walk us through one of them, and I think we'll take the first break. During the break, I'll try to merge it together, and when we come back, we'll continue. So in this sales now, this one gives us information of all of the purchases that have been made, starting with the order date, the stock date. Okay, I think we looked at this before. Order number, product key, column, customer key, territory key. Do you have 1, 2, 3? Even this one can be 1, I don't know. But 1, 2, 3, 4. We have about 4 keys here, but none of them is even what? Is even is even unique, because other dates cannot be unique. You cannot say, okay, we only want to be making one order per day. It's not possible. So you definitely have two more. Look at this one, 2nd January, 2nd January. So automatically this is a foreign key. If you look at this product key too, you should know now, you cannot have, logically, you cannot have it. Because same thing as customer. You cannot say you've purchased with us once, you cannot come here again. No. You understand? Same thing as territory. Maybe people from US, so it's only once they can purchase our product. It's not possible. So automatically, all the keys we have here are foreign. So that makes it what? A data table. So that's that. So we should just take like 5 minutes break now. And during the break, I will just take questions if you have any. I will also try to quickly bring in a folder for sales. If you've not seen me do it before, you can just watch. I will not stop the screen, but we can have our 5 minutes break now. We'll be back by 8 o'clock. Sorry, my time. We should have 5 minutes break, yeah? So let me pause the recording. All right, guys. We're back. Okay, so during the break, I just brought in the folder. So instead of having 2015, 2016, 2017, we have all of them in one place. So if you missed out the first meeting, we showed how to import via folder. So you can always watch that. So now we have all the 2015 to 2017 data all in one table. Okay, so now we've established what type of we've established the keys in each of these tables. We've also ascertained the type of tables that we have. So now we'll go to our modeling, because after doing that, the next thing is to model your data. That's to join them together, basically connect them using those keys. So, okay, I think I have to bring this again. It's going far, yeah. So now the best practice that I really recommend is that always make your data table to be, it's not like it's just one of those things that I caught. So always have your data table to be somewhere at the bottom, then your lookup to be at the top. So this is there's a deep explanation behind that, what we know as filter context, but I'll not be going into that. So, but you can always do it as you want, but this is just best practice. So I'm going to bring, since we know that we have two data tables now, right? The sales table and the returns table. So I'm going to bring both of them to the bottom, and I'll have all my lookup at the top, okay? So now let's join them together. So let's start with which one can we start with? So someone tell me which one should we start with, then we'll do that. Then another person will tell me which table will go next. So guys, which table should we start with? Anybody? Are you there? Can you hear me?
Yes, I can.
So which table should we start with? Okay, nobody's saying anything. Fine. Okay, you can start with oh, you thought I was going to ask you? No, I'm not going to ask questions. I'm just asking which table we are going to start with. But it's fine if you don't want to answer. So we can start with the calendar. Okay. So calendar, because if you check your calendar, we already know by now that calendar contains just the date. So if you check it, we have the date. If you check inside of your calendar, you have just date, right? Just, I told you, like a normal calendar. So if you check your sales, you can see that we have dates that each order was made. So if I want to do anything about dates, now if I need more information as to, maybe I want to kind of group them into a particular date and all of that, I need to connect this order date to my date. So in this, I told you that this order date is also a key. If you remember, this is a key, this is a key, this is a key, this is a key as well. They're all foreign keys. So I need to connect this, my sales table, to my calendar date, so that if I need to group my order based on a particular date and all of, we are going to be touching them when we get to date time intelligence, right, in DAX. So basically what we just do now is in your calendar, you have your date, and in your sales, you have your what? Order date. So you just have to do is what? Just drag and drop. You are not writing any code like SQL, so you don't have to worry. So that is your first connection between them. Okay. For those of us that have used Excel before, you probably know all of these things. So, or maybe what's the name of this database? Microsoft Access. Yeah. So that's both of them. The same thing for returns. So because we have return date, if you remember, right? I showed you that we saw that together, return date. You also need to join them together to return date. That's the second one. Now, let's look at customers, okay? So, okay, another thing, let me point out to one thing, but it's, as you get deeper with your analytics journey, you would probably start thinking like this. Sometimes what drives your connections, because to be honest with you, they are different, like it is your objective that determines how you're going to model. That's the truth. It's your objective, what information you need. So if most times when you look at your data, when you're about to start something, you have your objectives. Okay, this is what you want to try to give insights on. So it is based on those insights now you model. So you might necessarily, if I have to do this thing now in like a real life scenario, there are some models there that I might not do. And there are some that I will even do, but I will not even show here. So it depends on what we want, but I can't be going so deep into all of those things now, so I don't scatter everything. So this is just like a what did I call a surface thing? Okay, it's not like it's difficult. I'm just saying that this is like a surface thing. Okay. Okay, so we have our customers. Now we want to join our customers to sales, right? So we can see that in our customers table, we have customer key, and same thing with our sales. We have that customer key, so we just join them together. Very simple. So this is our customer key here, and our sales, we look for customer key and we join them together. And you can see it's joined. This is it, right? So what else? So in our sales table, we have our product key as well, which represents our primary product key in our lookup table for product. So the same thing, you join them together. You can see, if you hover on it, it will show you, it will highlight the two things that you join together. Also in our sales, we have territory key, which signifies this sale, this is where they are buying it from. So that means you can join our territory key from our sales data table to our territory key in our territory lookup table. Very simple. So that's that. Now, what else can we do again? So if you check your returns too, in your returns, we have territory key. So if you want to see the territory that they are returning the product, so you can join the territory key from your returns data table to your territory key in your territory table. So you can see that the territory key is named territory key here, but here it is named sales territory key. So it's not like they have to be the same naming convention. I think I also mentioned that. So that's why it's important to know, not by their name. Not that you just say, this is customer key, that means automatically they are. No. You still need to investigate, look at it deeply, because sometimes they will not even have the same name. If you are working with an institution that bring data from different sources, from different countries, and they don't use the same naming convention, so how do you go about it? So that's why it's important to investigate, to understand what each field in your data represents, and then you will be able to do the correct modeling, not by the name. Okay. So now this is territory key. We've already joined them. Now you can see inside of our returns, we also have products. So if I can join this product key here to the product key in my product, you can see. Okay. Now what else do we have here? We've already joined dates. We've already joined territory. We've already joined product and territory and return date. So yeah, we've already joined customer key. We've already joined product key. We've already joined territory key, and we've already joined order date. So I think these were the 4 foreign keys that we highlighted when we were doing it. And here we highlighted 3 foreign keys, right? So that's that. So we've joined all these tables together. So now back to what I wanted to say about coming down, going up. Now, if you look at it, what is the arrow? You can see that the flow is like you are coming. Let me show you what I mean. You can see that this arrow now, it shows that you are coming from here to here. Can you see it now? It shows that you are coming from here to here. So that is why, that's exactly how filter context work. I won't be explaining it, but I'm just saying. So that's why I usually like to best practice, and based on some of people I see as mentor, they recommend doing it like this. So you can know that by looking at your model, you can easily say that this is your lookup and this is your data table, because your data will always flow from your lookup to your data table. Don't worry, it's just a pro tip. If you don't catch it, no problem, no worries. So now we have joined all of these tables together, yet we still have two tables that are outside. So what is wrong? What is it? Are we missing anything? No, we are not missing anything. Just that you can see here now, there's nothing like category name. There's nothing like category name that you can join here. So the only thing you can join this tree with is the products table. Do you get it now? We can only join it with the products table. So let me bring so that you can, let me just rearrange. I want the products table to be somewhere here, right? So now, if you look at it, this products table now, we have what we call product. Let me scroll down. You have product subcategory key. So that means it's for each product now, you can say, okay, this product belongs to a subcategory based on this key. So that means you can join this product subcategory key with product subcategory key inside of your product subcategories table. Can you see it now? Then if inside of your subcategory, you have what? Category key. So that means you can join your category key with your what? With your category key here. Just like you are matching them together. Can you see it now, guys? I think there's a problem. Hold on a second. Okay, is it correct? Yeah, I believe so. Okay, yeah, it's correct. It's correct. So you can see how it is flowing like this. So we are done with the modeling. As far as I can see, that at least this is the keys that I identified. This is the data, and this is how I feel I can join them. So let's say another person now might feel like, okay, he needs more information on order now, for instance, order number. Maybe there's another table that gives us order, blah, 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 blah. Then you can add more connections. But as far as what we have here, and as far as what I would like us to do, this modeling is done. Do you get it now? So that's primarily how it works. So two things that I mentioned earlier about this Snowflake that also come out in interview, I'm going to be explaining them now since we've completed our model. So we have two types of schemas. They call them schemas, or maybe connection, I don't know, just call them schemas. So you have what we call Snowflake, and you have what we call star schema. Okay, so in order to explain it, let me just demonstrate something for you. So now, if I click on star, and let's show ourselves an image of star. Now, how does this image look like? How does it look like? It means you can say there is something in the middle, right, that is connected to different things on the outside, right? So there's something in the middle here like this, and that thing is now connected to different things outside. So that's exactly how a star schema look like. So a star schema involves one table or two tables connecting with, like, they now have different branches. Do you get it now? So in this case now, if you look at this sales table now, only this sales table is connected to 1, 2, 3, 4. Of course, it might not look like a star. Maybe if you try to rearrange it, it might look like a star. So you see what I'm saying? If I bring this here like this, I bring this here, and I bring this somewhere like this, and I bring this somewhere like this. Is it not like a star? Is it not like a star? Like only this table now is connecting to 1, 2, 3, 4. Or let me say these two tables now are connecting to 1, 2. Is it not looking like a star? Exactly. So I just, it's not like you expect it to be like that star. Hey, sorry, this is international community. Sorry, it's to be exactly like that star. But I'm just trying to demonstrate that what it involves when a table or two tables are now connected with what additional tables on the outside. It's called what? A star schema. Then we have what we call snowflake. So snowflake is just like a snake. So that means it's like a line, which is exactly what we have here. These three, 1, 2, 3. You can see that what? We have them on a line. Do you get it? So this is connected to this, and this is connected to this. So this is not connected to this directly, no. but this is connected to this, and this then is now connected to this. Is it clear, guys? So in these three now are what we know as what? Snowflake schema. It's mostly used for hierarchical data, which in this case is like category, subcategory, product, or country, state, city. Do you get it now? Hierarchical, that shows like a level. Federal government, state government, local government. Do you get it like that? So hierarchical data, that's what they use Snowflake for. So, but star, you can see it means what? When one or two data are connected to what? Several other data directly. You can see there's no intermediary, but here there's an intermediary between this and this, which is what? This. So those are the difference. It's an interview question as well. Difference between Snowflake schema and star schema. It's as simple as that. You can just go online and look for complicated definitions. Well, it's up to you, but the way you can easily remember and understand and even explain. So that reminds me, one more thing. When you're in your interviews and they ask you questions, don't just give them definitions. I know you probably have heard this before, but to be honest, in fact, another thing I can recommend is another trick is this. When they ask you one question, use that question to answer like 2 or 3 questions that you know that they will ask you. So for instance, okay, let's just do a little bit of career talk. So for instance, okay, this is how it goes. Okay, let me just, let me just give you a scenario. Of course, the most likely question you are likely to be asked in your interview, the very first question is that, tell us about yourself. One mistake I've done in the past, or for many people I've also done, is the fact that tell us about yourself. Okay, see, is that an opportunity to start telling them, okay, you grew up in Yaba and your parents were this, you started IT because maybe everybody in the family, nobody knows about computer, and you're so motivated by that, blah, 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 blah. You tell them without making any reference to what you have done. So I recently learned that, and see it as an opportunity to tell them what you have done. Although the question might sound like, tell us about yourself. No, you can just tell them little, okay, this is my background. I got interested in data analytics because of this. And so far, so good, I've been able to do this, do this, do this, do this, do that. When I was doing this, this is what I did. This is what I used. This is how I did it. And make sure you mention as many terms as possible. That's why I'm telling you all of these things, all these schemas. Use those terms, schemas. Don't just say data. Say table, use all of these things. When they ask you about tables, tell them data table. Most people know it's data table, but not everybody know that it's also fact table. So you can say data table, where some people call it fact table. You tell them like that. You give them, bombard them with all of this information. It only gives an impression that this guy is not just coming from a Google definition point of view, but also this is what he knows. And is able to handle it well. Okay, so most of the time, in most of my interviews, I try as much as this is where I focus on this modeling part, because I know this is where they are coming, right? So I come there myself. When I'm telling them all the things I've done, when I get to this area, I tell them, I don't just tell them that I model data. I will never stop there. I used to do it in the past, but at least for the last interviews that I did, which were all successful, I never stopped that I did data modeling. No. I did ETL processes, extraction, transformation, loading processes. In the extraction, I connected to an Excel file. Sometimes I connect to CSV file. And when I bring it inside of my Power BI, I perform some transformation processes like changing of text, modification of the date, and even some conditional formatting or conditional colons. For instance, most recently, I have a colon that had annual colon, and I felt okay, that was not okay. That's not that will not give us the information, and I used calculated colon, a function in Power Query. You tell them the tool you are using, be specific in Power Query. Like you are doing it really. In fact, they will get lost of the question they will have to ask, because you've literally answered everything. So be very, very specific. And when you come to this, tell them, well, I've been able to, in my last project, I worked with a star schema, But in the past, I've also worked with a Snowflake schema. You might be wondering what's the difference. Okay, star schema is this. They did not ask you. You know, all we are assisting is tell us about yourself. But you've been able to augment everything together, walk them through. You are telling them about yourself. So I'm telling you about what I've done in the past, which is also about myself. So I'm just giving you a more streamlined explanation. And before you are done, in fact, they just look at their book and okay, they start looking for another question. It really works, guys. So these terms, be very familiar with these terms, know them, understand them, go beyond book definition. So 4 minutes career tip done and dusted. Let's move on. Sorry. Okay, so we are done connecting this all of these things together. So I've also showed you the difference between star schema and Snowflake schema, right? All right, then the next thing we move on to is our visualization. Okay, so since we've done the first step, which is ETL process, which is extraction, transformation, loading, the next thing is to do the data modeling, which we have also done and has given us familiarity with all of this data. Now the next thing will be to start visualizing. But before you visualize, most of the time you need what we call DAX function. If you are working with Power BI or Power Pivot, Power in Excel. So DAX function is just an engine that Power BI runs on. It's known as data analysis expressions. And at the moment, there are over 250 DAX functions. Of course, I don't even know I don't know what I do. But I know that when I need something, I can always go to Google and say, okay, I want to do something like this. So I'm saying that because you don't need to put all the 250 on your head. No, but I don't think anybody even knows up to 100 that have. So everyone already so it's about use case, what you use often. And what are these DAX functions? They are not something to scare you. They are just formulas, just like Excel formulas. Just that they are a bit different in the structure. They don't use referencing structure. In Excel now, if you want to write formula, it's okay. Cell A1 to A colon B2, it means A1. No, they don't use that kind of reference. But it's still like what? Functions. Right? So let me quickly, I think I showed it. I have a slide here. Sorry. So I have a slide here. So these are just the ones I was able to see. They are, like I said, over 250 of them. So they are quite simple. If you are very familiar with Excel, some of these things you will find them very handy. But if you are not still familiar with Excel, don't worry. It's still something that you can easily back up. So this resource actually group them based on different categories. So we have math and start function. So in Power Query, if you remember, we had them too. And I told you they do a what? Aggregation. I think I explained what aggregation means. It means you work on 1, 2, 3 or more data or values, and you return one result. That is aggregation, right? So if you remember, we said the example is sum, average, and all of these things. So exactly the same thing. We have these functions in DAX. So we have sum, average, we have max, min, which is maximum, minimum, divide, count A. There's a difference between both of them, but I don't want to bore you too much now. We'll probably still see. Then we have count rows. So they are readable, right? Most of them, they are readable. Once you see, it's okay, this is what it does. So count rows now, it means you are going to count the number of rows in that table. Then distinct count. By now, you should have said distinct a lot of times, so you should know what distinct means. So you can have 20 rows, but distinct can be 5. It means the individual, you want to be counting them 1. So if you have a value appearing 4 times, you want to only count it as 1, distinct. So that's like distinct count. Then we have iterator functions. These are there. Don't worry, I'm just showing you. It's not like maybe I've covered it like that. We have logical functions. So logical functions are Again, if you are familiar with Excel or even any programming language, you know all of these things. Conditional. Even if you don't know it, when we were doing Power Query, if you remember, it was saying what? If something. You know, when we were doing Power Query and we had annual salary, we said, okay, if a salary is between so, and so, then we return what? I. Abi? Is that not how we did it that day? If this is this, if, you know, condition. So there's a condition. Okay, if this criteria is fulfilled, then do this. Otherwise, do this, you know. So that's known as logical function. So you can see we have if error, and, or, not, true, false. So these are, then we have text functions. So text functions are what you can help you work on texts. If you remember when we were doing I think we're replacing, right, in our power query. But that replacing is more like we have UI to help us. You can go to replace and click on replace, do this, do that. But this one is just a function and it's going to do the same thing. So concatenate means joining one or more strings together. Format, what does format do here? Okay, I can't really remember what format does here. Left, mid, right, and so on and so forth. Then we have filter functions as well. Then we have date and time functions. So this will come very handy with any table or any column that has to do with date. So let me be very sincere with you. When it comes to DAX, even the experts, I mean, I don't know if I mentioned in one of our classes, I participated in a challenge late December last year, and it was like 25 days of DAX, and it really opened my eyes because I felt, oh my God, why am I so, you know, I like that feeling anyways, that you don't know anything. It's a good feeling, but it's not good if it's too much. Like you start having low self-esteem. So that was what I was going through with DAX, and it was when I joined that challenge, I realized even those who are MVPs and all of that, they were getting it wrong. Or don't let me put it that way, they were also, everyone is in a learning process, right? So it's a learning process. Over 250 dash function is not small play. So most of the time you get to use it based on what you are doing. Okay, so the major thing is understanding how to write it and how to come up with what you need, because you have a lot of them. So which one do you need at this time? So it's not to scare you. So no problem about that. Okay, so I will go over now to Power BI again. Any question, guys? I probably said a lot of things. Any questions? Any questions? No question. Okay. Now before okay, go ahead, please.
It's not a question. I just want to like appreciate the like little career tips you chip in. It was really, really helpful.
You're welcome. No problem. All right. So now we are back to DAX. So in Power BI, or let me say, as far as DAX is concerned, please write it down if you can, or maybe when you're listening to the recording. So we have two things that I want you to take note of. We have what we call calculated column and measures. Calculated column or fields. You know, in data, they call columns fields. You know, it's known as field. All this column you are seeing is field. This is other quantity field. So you have calculated field and measures. It's a very tricky part of, in fact, they asked an interview as well. And so many people till today still don't know the difference per se. Because if you check in your Power BI, it's very easy. You have both of them. You have measure and you have column. So what is the difference between them? Well, you know, I always put it simply, the way you can easily understand. You can always read further on it. Calculated column, although it says calculated, but what it does is it's going to create another column to your data. You are going to be seeing it. That's the implication. Just like when we were in Power Query, and if you remember in customers, we created another column, salary range. This that we did, if you remember, you know, we said if anything greater than blah, 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 if you remember, we could also do it here using DAX function. So, but by the time we are done and we have a new column like this, it is known as what? Calculated column or calculated measure or calculated field. Do you get it? So And another point about it is that it usually involves things that are not numeric. So it's going to appear as a textual thing. Like, it's not going to be like numbers. Even though you might have numbers, calculated colons are not going to be like, you cannot use them as numbers. You cannot use them to calculate. You understand what I mean by that? So, while measures, on the other hand, are like opposite of what I've said. So measures, when you create measures, they are not added to your table. You don't see them. Okay? So they are somewhere stored because they are what? They are numbers, and they are very flexible. So by the time we start, we'll see what I mean by flexible and all of that. So those are like the two simple definitions I will give to you. So your first assignment is to tell us, you go and find out the difference between calculated colon and measure. That's your first assignment today. Calculated colon and measure. But I've given you the simple understanding of it. Calculated colon, you will always see it. It will be added to your table. But measure, it will not be added because it is numeric. They are metrics, they are numbers. But calculated measure, well, they can be numbers, but they will not be seen as numbers. They are rather seen as what? As values in a column, which can be only used for filtering. Don't worry, you understand what I mean by that. So now let me use this one so that because you can easily relate with it. So I want to create a calculated column now based on this, right? I want to create another column that will give us the same thing that we have here. So let me quickly go to let me see the bins that we used for that. Let me see, additional column. Let me click on this settings. I just want to see what we used. So we can see we said if it's less than 35,000, low. If it's less than 65,000, average. Then if it's greater than 65,000, high. Okay, so I'll just close this. So we are going to create the same thing with DAX. Okay, so this is how you create DAX. So you can create it in any of the views, either in a report view, either in data view, either in model view. All you just need to do is hover on the table you want to create it on. Although I have another best practice for creating them, but don't worry. Well, maybe when we do measures, I will show you. So now we want to create it under customers, right? So I can hover on customer now, right click on it, and you have two options. You have new measure, and you have what? New column. Or new calculated column. Don't worry. I think calculator will be too long for this. So new column. So when I click on new column, bam, it's going to give me a place for formula, just like you have in Excel, something like this, where you can write your formula. And you can see here that what it has added a column for me. So all I can start with is, you can start with the name of the column as you want. You can see, because we have column is equals to, this place is already named column. So if I want to rename it now, I can just highlight again and say maybe salary range 2 equals to. Don't be too don't feel somehow about this formula I'm about to. I know I've not showed you what logical functions are and all of that, but I just want to demonstrate the difference between calculated column and measures. That's exactly what I want to do. Okay, so don't worry, we are still going to be touching those functions, some of them one after the other. So the same thing is the idea. If you check in that slide that I showed you, you can see we have if function, which is exactly what we did with that salary range. We want to say if it is less than this, then do this. Do you get it? So we're going to start with if. So I'm going to say if you are familiar with Excel, this shouldn't be a problem. So if, now we can see it is, the IntelliSense is very okay. It gives us a number of options. So you can always, even if you want to know more about what each of them say, you can click on this thing, read more. It's going to tell you, okay, this one check whether a condition is met, blah, 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 blah. So, but what we want is just if. That's so I can use my arrow to come down and just press on my tab. It's going to automatically open a bracket, or you can be typing it manually, which is not efficient. So just use your tab. Once you have seen the function, just use your tab. It's going to open a bracket for you. So now you can see it's telling you, just like Excel now, right? For those of us that use Excel. So it's telling you the argument in this. It's telling you you must have a logical test, the result if true, and result if false is in brackets, right? So meaning it is optional. Just let me open Excel so that you can see that it's the same thing with Excel. That's what I always tell you. See, Excel, you cannot escape it. I was reading a trend recently. A data science was saying Excel, you can, no matter how they paint it, Excel is for everybody, and it's there. As far as this moment is concerned, the time I'm recording this video today, I don't know of tomorrow. If you want to start analytics journey, I always recommend start with Excel. If it's machine learning, if it's data engineer, whatever, start with Excel. It might look like, okay, it's our data, it's for office, it's this and that. Start with it. Don't just jump to Python. Don't just jump to all of these things. It's as basic as it is, it gives you that foundation that you need. So if you check it now, if function, we have it also in Excel. Just you can see it's the same thing. Logical test, value if true, value if false. So if you have experience with Excel, then you probably have seen this before. If you don't, no problem. You can always see it here now. So logical test is saying that what is the condition that I want to check? Okay, so what is the condition that we want to check? So the condition I want to check is that if this annual column, right? So that's if this annual column. So I can just type annual column, just type the name. You can see it's going to, you can just type it anywhere. I think even if you type income, maybe it should bring something. You can see. So anyhow, maybe you can just type it anywhere. It's going to bring that column. So it has brought this column for you now. So you are saying if this column now, so if I click on my tab or if I click on it here, I always use tab most of the time because I cannot be holding mouse all the time. So just use your tab, it automatically select it. Okay. So if now that we've created if now, we want to now check if this thing now, that's this annual column, if it is less than, just the traditional way of writing it, less than 35,000, right? This is the test. This is what we are checking. If it is less than 35,000, then comma. So you can see by the time I put comma now, it comes to what? Result if true. So that means if this condition is true, what do you want me to do? Then I want you to return low. So because low is a string, we need to put it in what? In quotation. So I'm going to say low. Okay. Then comma again. So result if false. So if it is false, so let's assume this condition is not met. What do you want me to do? Do you want me to go and sleep? Or do you want me to close? Or do you want me to do another thing? Yes, I want you to do another thing. So now if this condition is not met, okay, let's say it's starting with this one now, this first row, and it checks now, okay, 70,000, is it less than 35,000? No. So it moves on to the next one. So I want you to now check again. If that same annual column, if it is less than 65,000, right? Then what do I want you to do? I missed something up. Wait. Okay, it's saying result if false. So result if false, I'm going to create another if function again to check for us again. So if, again, you start all over, this is called a nested, don't worry, we'll probably still cover it. It's called nested. You are checking different conditions, right? So again, if that annual column is less than 65,000, right? Then the same format, return what? Average. Okay. And the last condition is what? So if this condition is not met again, which in this case, for instance, 70,000, it cannot be met again. What do you want me to do? Do you sleep? No. I want you to check again. So you say if again, that annual column is greater than or equals to 65,000. Now it has to, because here we said less than. So if it's like 64,999, it will still be average. But the moment it is 65,000 and above, that's greater than or equals to, then I want you to return result if true. I want you to return what? I. Sorry. Okay, then what? I close it. Now I have opened this if 3 times. Well, DAX is very smart. Once I just click on enter, it will automatically close them. So you don't need to. But if you want, you can always check. I have opened if 3 times now. This is 1, this is 2, this is 3. So if I want to close it now, I will need 3 close bracket. But if I press enter, DAX will automatically close it for me. And boom. You can see our colon has been created here, which is exactly the same thing as the salary range we had here. So the same thing that we did inside of that Power Query, this is exactly doing it with DAX. Can you see it now? So this is how DAX, this is calculated colon. You can see now that we have that colon added. It is showing here. Okay. Now, let's now assume, let me show you another measure. Let me show you measure now, and you see the difference. That's the key thing, what I want to show you here now. So now let's assume I want to, let me see what I can say. Okay, let's assume I want to calculate the sum, the total sum of this income now. I want to add everything together. You know, that's like talking about adding numbers, right? You want to aggregate. Don't forget, I want to work on all of these values and return what? One result, right? Do you remember that's what I told you about aggregation, right? So you need to use an aggregate function, which in this case, we want to add them together. So you can easily use sum. So now I cannot use calculated colon for that. Okay, let me give you another point like that way. You cannot use calculated colon for aggregates, for aggregation. You can only use what? Measures. Measures are only used for aggregation because they will only give you what? One result. Do you get it now? So now I will be demonstrating 2 measures. The first one will be to add all these things together, all this income. So how do I go about that? Again, I'm going to right click on it, but this time I'm not going to choose new colon. What will I choose? New measure. Okay, so it's going to bring the same thing, the same formula thing. So I can just write total income now equals to. Are you following, guys? Hello?
Yes.
That yes is some. Are you tired?
Yes.
Yes.
Okay. So total colon now equals to. I'm not showing you functions here too. My key, what I'm showing you basically here is still the calculated colon and measures. So sum, I want to sum. Now look at it. It's asking me for colon name. That means the only thing that this function can accept is what? A colon name. So now I can say the colon is annual income, right? So annual income. And by the time I click enter, it will automatically add the close bracket. So once I click on enter, you can see that we have total colon. Now look at it. Do you see anything like total income in this place? Is there anything like total colon in the colon now?
No.
No. You understand? But you can see it here. And look at the sign. Calculator sign. So that tells you this is a what? A measure. But look at this one that we created. Look at the sign. It tells you what? A calculated colon. You get it now. So now how are we now going to use it? How are we going to use it? I told you it is stored in the memory, but you cannot see it. So if you want to visualize it, I know we've not got to the visualization, but I'll just demonstrate this. So let's say I just place a card here and I want to look at the total income for all the customers that we have here. By the time I just click on this total income now, you have the value here, 1.04 billion. So you can see now that even though we were not seeing it here, the moment we summoned it, it came out. Do you get it now? So that's how measure work. Another thing I want to show, it's still the same measure, but I want to show you count now. So let's assume I want to count the total number of rows that we have here now. So if you look at it now, we have 18,148. So that's what we should get. So I want to write a new DAX function. So I'm going to write new DAX measure. So I can call it count of rows. Your naming is not an issue, so whatever you want to use. Count of rows is equals to, now I'm going to use a function called count. So we have numerous counts, but the key ones, the 3 ones I want to show you now are count A, and count rows. Okay, and distinct count 4. Okay, so please listen now. It's more like I'm treating the function now for that count. So what does count do? Count basically count, sorry. Yeah, pardon my tautology, but I have no choice. So count basically counts numbers. So if you are using count for a colon, it will only count the numbers that are there. Do you get it now? That's what count does. It only counts numbers. So if I have this now, for instance, I have a colon like this. I have 2, I have 4, I have 7, I have B, and I use count for this. It's going to return how many? 3, because it can only recognize 3 numbers here. That's what count does. But count A is like count all. So far that value, that place is not empty. Even though it is a number that is there, even though it's a non-number that is there, just take that A as all. Just count everything for me. But to not count blank. To only count a colon that is what? Occupied. A cell that is occupied. That's count A. Then we have count blank. This is from the name. It counts blank. No much explanation on that. Then we have distinct count. So distinct count, I think I mentioned that earlier. If you have a number appearing 4 times, it will only count it as 1, right? So by now you should know the distinct count. So that's literally what those counts mean. So now what we want to do basically is, then we have count rows. Again, this by the name you should know. So it's going to count the number of rows that you have, right? Irrespective of whether it's blank or not, or all of that, it's going to count everything that you have, the number of rows. So what I just want, I can just use count A. Many a times, those counts can be used interchangeably, provided it is still going to give you the result you expect. So in this case, if I use, because I know that all of these things now, they are numbers, I can use count. I can use count A. I know that there's no blank. I can use count rows. You understand? Like, so in this case, now I can use as many as I want. So I'll just use count A. Then I'm going to count customer key, colon. So let me call it customer key. So I just want to count it. So by the time I click on enter, again, it's not appearing anywhere, but you can see it here as what? A measure. Now, if I come to my, don't worry about this one. I know we've not got to the visualization. I'm just demonstrating. So if I click on my count of rows, you see that it is the same thing that we have, which is 18,014. You might be saying, why is he aggregating it? I need to format it here. I need to click here and format it to O number. General first, let me see. Sorry. How do I take this K off? It's not even on my head right now. Okay, let me see if I have this one. I don't know why. But okay, I don't even know why it's not working, to be honest. But of course, that's correct. 18 point something, as you can see. I don't know why it's giving us as K. Come on. See, let me leave that one there. So that will not waste our time. But of course, 18.1K. If I maybe make it 2 decimal place, maybe you would see it with 2 decimal place. So 18.148. So if I make it 3 decimal place, I have 148. Yeah, which is exactly what we have. So that's calculated colon and measure. Do you get it, guys? So calculated colon, you see them on your table, right? And what the other one, you will not see it, but you will only be summoned. Now, look at what I mean by that. Calculated colon cannot be used as numbers. If I try to bring in my salary range here, you can see it's not giving me any number, right? It will never give you a number. So it will only be seeing it as a filter. Don't worry, when we go further, you understand. When we start visualizing, you understand what I mean. So I think we can stop here for today. Excuse me. I think we can stop here for today. So please try to go over that modeling again, please. If you can watch the video, if you can read more resources on it, try to see, look at that data, understand why this one is data table, understand why this one is lookup table. You understand? Look at it again. try to see that data, try to bring out just in by your own self, with what the understanding you have so far or previous understanding, try to see what these data are telling you. Because very soon I will start working on visualization, and your visualization will be based on the insights you are able to see as an analyst. So there's nobody that will write it for you that, these are what I want you to know. As an analyst, you have to look at this data and say, what information will make sense here? It will be okay to look at what is the ratio of men and women that patronize our order. You know this kind of thing. So these are like insights. So, and it can only come the more you understand the data, the better the insights you're able to bring out from the data, right? So this is what I want you to look at this data, or look at this modeling that we just finished. Then also these DAX, I think with this calculated column and measures, I think the explanation, you can also build on that if you want, try to read more on it. But I will be more interested in you checking out DAX functions before the next class. If you can watch video on it and try to work on it, DAX functions, just look at how they are writing it. Look at how it's very simple, just as you can see. But I just want you to be a bit more familiar with it before we meet. So by the time we meet, we'll try to look at some simple ones that I know that you will definitely be using as an analyst often. Then after that, we will now look at it in relation to this particular table that we have been working on. So I think we should start with our insights next week. We'll look at this table now together and everybody will contribute. So what insight do you think we can bring out from this data? I've already given you an example now. Okay, so what product is selling most? These are like insights. What product category is selling most? These are insights. Who is your best customer? Or what is the best selling product in terms of profit? What is the best selling product in terms of revenue? There are different things. So these are things I want you to be thinking about. Which territory are we getting a lot of orders from most? Or which territory are we getting a lot of returns from most? Which product are they returning most? I'm already giving you the answer anyways, but I just want you to open your mind and look at this and what do you think we can bring out? Don't worry, if it doesn't make sense to you, just write it. Just write it. We will all look at it and we will now decide if it makes sense or not. We are still going to be doing some transformation. I'm very sure of that, because we will need some things and we don't have them yet. We need to derive those things. You understand? So it's not a complicated thing. We probably do it in Power Query. Just derive those things from what we have already. For instance, profit now. There's nothing here that tells us profit. But if you check your products table, I'm just showing you what I mean by that. If you check your products table, we have product cost and we have product price. What does it mean, guys? How do we get our profit? Selling price minus product cost. Is it not it? So those are like the simple transformation that we'll be doing. You understand? So, and work on them. So I just want you to be involved now, right? It's getting more interesting. I'll be visualizing, you'll be seeing a lot of things, but I want you to also like be anticipate it, right? Anticipate it, look at it. And I don't know if you can find any resource on YouTube that can show you, because AdventureWorks is a popular data set, like I said. So you probably can find a tutorial that has walked through this adventure. It might not look exactly like this, but I just want you to start thinking like an analyst now, right? Start developing your mindset like an analyst, so that we're not just rigid about the whole learning thing. I want you to also contribute, to also participate, to feel involved, and that's the essence of this as a community, and not just you watching a YouTube video that has been recorded. So with that, I think we can wrap up the class today. I don't know, I can't promise, to be honest, because my schedule it promises to be tight this week. But if I can lay my hand on another data, maybe that will have 2 or 3 tables, I can send it on Discord and tell you to identify. No, put it in upload it on Power BI. Yeah, I would definitely get. Don't worry, I would definitely get. By God's grace, I would definitely get. So probably before Tuesday, on Wednesday, I'll try to get it. So you're going to look maybe just 2 or 3 tables. It won't be a lot of things. So you will look at it, try to model them as well, right? Then I just want you to have like hands-on, just to, then I would see. Okay. So any question, guys? Please, if you can remind me, sorry, if you can remind me if you don't see anything on Tuesday, please just send me a reminder. Then I would definitely get it across before Wednesday. God's grace. Okay. So at this point, do we have any questions? Any question, guys? You can go and stop the recording now.